Good morning, class. This is your lecturer, Dr. Sandro G. Catane. We are now in Lecture 3 on Aeolian deposits or desert environment. Deserts are regions of the Earth with mean annual precipitation of 25 centimeters or less. They are mostly related with descending air currents. These are latitudinal air currents called Hadley cells. Deserts are distributed along a belt at 30 degrees north of the equator and also 30 degrees to the south. As you can see, many deserts are situated within this belt. Other cases, they are formed in rain shadows of mountains, areas located at a significant distance from the oceans can form desert or Aeolian environments. There are cases where tropical coasts adjacent to cold ocean currents producing dry air can also form desert environments. And other areas where you can form desert is in polar areas. Earth's general air circulation. The rising and falling of air, as you can see in this diagram, these are patterns that creates vertical wind convection cells called the Hadley cells. Hadley cells are responsible for much of the arid lands that we observe in the north and south of the equator. Because all of the warm, moist air is sucked out in this region and redistributed to the north and south. Desert originates by several different mechanisms that is a result of several different types of desert. We have subtropical deserts. The general circulation brings dry subtropical air into mid-latitudes. Examples of this are the Sahara of North America, North Africa, sorry for that, Kalahari of Southern Africa, and the Great Australian Desert. Continental deserts, like the one in Western Australia. These are areas in continental interiors which is very far away from the source of moisture where hot summers and cold winters prevail. Examples, Gobi, Taklamakan. In some areas, you have rain shadow deserts. These are areas where mountainous regions cause air to rise and condense moisture drop as it passes to the mountains. Examples of this are desert of the Sierra Nevada mountains, California and Nevada, east of Cascades in Oregon and Washington, and east of the Andes Mountains in South Africa. You produce an Aeolian or dry environment at the other side of the mountain range. Next is coastal deserts. Areas where cold upwelling seawater cools the air and decreases its ability to hold moisture. Examples of this, Atacama Desert of the coast of Peru, Namib Desert of coastal South Africa. Polar deserts, these are cold polar regions where cold air prevails and moisture available remains frozen throughout the year. Examples of this is northern Greenland and ice-free areas in Antarctica. Wind as an agent of weathering and erosion is not as effective as water because wind is not chemically active. However, wind can be effective as an erosional and transporting agent. Wind action is strong in desert because of low humidity, great temperature ranges, more effective because of the lack of vegetation, and wind is an effective erosional agent in desert because sediment is, it takes 200 kilometers per hour for wind velocity to move significant amounts of sediments. The borrowing power rises exponentially as wind velocity continue to increase. Wind erosion and transportation. Wind erode particles. Movement is mainly saltation, also suspension, especially for finer particles, and for heavier ones like boulders, some boulders and pebbles, movement is by creeping. These are Aeolian particles that are generally well polished, well sorted, mostly composed of quartz grains, but this depends on what is most stable and available in the locality. These are bentifrax. It applies to a stone or pebble that has been shaped, worn out, or polished by abrasive and sandblast action under desert conditions. It results to this nicely shaped boulders and pebbles, and these are quite common in desert conditions. This is AR dung. This is also AR dung. AR dung is a wind-sculpted streamlined ridge that can stretch for over a kilometer in length, maybe 20 to 30 meters in height. It forms when strong winds blowing primarily in one direction remove all the sediments in the area down to the bedrock and leave this landform on the surface of the desert. Deflation is a very important process in Aeolian environment. The wind erodes the surface of the earth, and this process is called deflation. It is the winnowing out of finer materials that eventually results in a surface that is paved, comprising of pebbles and cobbles as sediments. This is what we call as the desert pavement. These are actual desert pavement, and this is an ideal desert pavement. And notice that it's devoid of finer sand materials. Deflation can also form blowouts. Blowouts are formed given this setting where sediment is saturated and we have wet sediments beneath, bounded by the water table, and we have dry sediments on the surface. When wind action erodes the dry sediments, you form these various saucer and trough-shaped hollows, and this is formed by wind erosion. The resistant area, which is normally stable, sometimes grown by vegetation, it's called a pillar. This other diagram shows a blowout and a pillar. The pillar being formed due to the presence of vegetation. Loose is a homogeneous, typically non-stratified, porous, friable, slightly coherent, often calcareous, fine-grained, silty, pale yellow or buff, wind-blown sediment. And they are found in certain areas around the world. And in this map, it shows the areas where you have observed loose deposits, these orange areas, and the yellow areas are the ones where they are possibly or probably found. Loose deposits are geologically unstable and they will erode very readily. Loose tend to develop in highly rich soils under appropriate climatic conditions. These are areas which are most agriculturally productive in the world. Some civilizations develop in loose deposits. Now we talk about the transport and deposition in an aeolian environment. The main transport processes are siltation, suspension, and creep. A specific term for the erosional capacity of wind action is called deflation, where fine-grained sediments are selectively removed from the coarser sediments, leaving behind mostly gravel and pebble sediments in the area. Deposits, the fine-grained deposits composed mostly of silt, it's called loose deposits. We call also gravel pavements for those coarse sediments left behind by deflation. We have spectacular landforms that can be produced due to wind action. That includes sand dunes and wind ripples. Generally, the products of aeolian action are well-sorted, well-rounded sand grains composed mostly of quartz, feldspars, lithic fragments, and other fragments. It's worth noting that normally the grains or the particles are composed of the more stable minerals. Sand dunes are asymmetrical mounds with a gentle slope in the upwind direction and steep slope called the slipways on the downwind side. Sand dunes can form when there is a ready supply of sand, steady wind, and the presence of obstacles such as vegetations or rocks. And sand grains tend to drop out from the mounds. That becomes a dune. And dunes can migrate laterally, such as shown in this diagram. Aeolian migration and deposition. Dunes migrate up the windward side via rolling and siltation. Grains are blown off to the crest of the dune and fall on the steep side. The accumulation of grains on the upper part of the dune causes oversteepening and results to grain flow. Particles are eroded here and redeposited on this side of the dune. And migration of dunes is to the direction of the wind, which produces this cross-bedding that are dipping parallel to the slipways. The angle of repose for dry sand is 34 degrees. This is the upper limit or the maximum angle at which sand grains are stable. Types of dunes. We have here 4 types. Barcans, parabolic, transverse, and longitudinal dunes. Take note that the wind direction or wind strength is very important in the resulting dune form. These are some other types of dunes. Notice the difference in morphology. The next slide shows some of the spectacular photos that were taken in desert environment. These are Barcan dunes. Next. Next. It's a small lake in the middle of a desert. Examples of dunes. Here as well. Next. Now we go to streams and fluvial landforms. Rarely we have water in desert environments. Streams tend to be intermittent. That is, flowing water is only available during rains. And for this reason, flash floods and braided streams are common. Playa lakes are standing bodies of water. It's similar to lakes basically, but it is quite rare in desert regions because of the limited rainfall and input from streams that occur in a very irregular manner. Iselbergs, this is a term derived from the German language. These are steep-sided hills that rise above the surrounding area. They are normally made up of more resistant rocks that were eroded less compared with the surrounding. This is an example of a playa or lake in the desert region. The next slide shows the Ayers Rock. They call it locally as Uluru in Australia. It is an iselberg. It is the largest exposed rock in the world, and it is made up of ironite, composed mostly of feldspars, conglomerate, and quartz. Are pictures of cross-bedded deposits. These are Aeolian deposits with large-scale cross-bedding. It is possible also to develop ripples on a dune. So what are you looking at is a dune and ripples are developed on it. Let's look at a local example of a desert environment or Aeolian environment in the Philippines. It is found in the northern part of Luzon. It's in Ilocos Norte, and we call this area as Ilocos Norte Sand Dunes. It's one of the National Geological Monument of the Philippines. The area stretches from the Lawag area near the Lawag River down to Paway. So for geographic location, this is Paway town, and this is Batak, and this is San Nicolas, and this is Lawag. This is a photo showing the sand dunes in Ilocos Norte covered by thin grass. And as for the origin of the desert environment in Ilocos Norte, it is probably formed due to rain shadow of mountains. And how this area was formed, how this arid environment formed in this part of Luzon. As you know, rivers flow from east to west, from the mountains of Cordillera down to the western coast of the Philippines in South China Sea. So this river is flowing to that direction as well. And longshore currents transport sediments in the shallow seashore areas to form subaqueous sandbars. And shore wave movement because of string of wave actions to form beach deposits. Reworking by wind action caused landward migration of dunes, and these dunes block water coming from tributaries and cause flooding in the surrounding areas. Through time, impoundment grew and evolved into this Poway Lake. Poway Lake may be considered as a playa because of its setting. Of course, there are sand waves in Lawag, sand waves or sand dunes, but it did not form or it did not block the river and form a lake. It is probably because sediment accumulation from the produced by longshore currents is not enough and that dune migration is slower. It's also possible that the erosive power of Lawag River is more than sufficient to erode whatever sediments is distributed by longshore currents. The next slide shows the sand dunes in La Paz, Lawag City. And you can also see the internal structure of these dunes in the same area. You can see the very nice internal lamination here. And for this, you can see a series of cross laminations. And you can see also the bed forms and series of dunes. This is a cross section of a dune in La Paz, Lawag City. Diagnostic features of Aeolian deposits are summarized in this slide and the next slides. Please go through these slides for the details. This ends the lecture on Aeolian and desert environment. Thank you for listening.